Hey everyone, welcome to the channel Codefarm. So this is yet another video in the series about system design that we are covering. Topic for this video is rate limiter that we are going to cover in very comprehensive detail. So before we start the rate limiter content video, let me show you something. So this is the GitHub page that I have linked in the description box as well, and I'm showing you in other videos as well. This is important actually. So if you say that you know about system design, these are the topics, go through it and see if you know everything about these or not, and if you are able to understand this or not. So my target is to cover these things in detail, whatever I have mentioned in here and whatever coming topics that are there I come across. And if you have anything in your mind, put that in comment section as well. So this particular video is the part of this one, system design for popular application. Previously we saw unique ID generator along with the implementation. This video we are covering rate limiter. So let's jump to that. First thing first, let's cover why we need a rate limiter. So let's see some of the example use cases around this one, right? So we all have account on the social media, right? So if let's see if it is x.com, previously it's Twitter, we have account on Gmail, we have account on LinkedIn and many other as well, right? So if you have experienced this or not, if you try to create these posts, before post, even if you try to create accounts on these one, X, Gmail, LinkedIn, so there will be a limit. Let's say I'm trying to create account from my laptop and I have created 10 accounts, let's say, and if I want to create an indefinite number of accounts, I won't be able to. After certain point in time, I'm not sure about the exact number, but after certain point in time, this will start throwing an exception that you are no longer allowed to create account on this one. This is applicable for all X, Gmail, LinkedIn. Okay. Another thing, like you have created an account, let's say you are logged into account, try to create the post on the Twitter, right? There will be a limit on that as well. So you won't be able to post the new post after certain point. Let's say that limit is like you have done 10 posts from your account. After that you won't be able to do that. Even if you change your laptop, change your system as well, if account is same, you won't be able to post more than that. So you see, there is a restriction coming into picture. There is a limit coming into picture if we are interacting with these service providers. Why they are there? That is the thing. So these services are created for all, right? So for all, or I say that there is a term fair usage. Fair usage, it should be there. So if they have not put any limitation on this one, I can go ahead and create n number of accounts from my own system, from my own laptop, and I can create indefinite number of posts from my account. So what will happen, because those requests are being processed by servers that has limited resources, right? So if they are used by from one user from one location, what about the others that reasonably they want to use it, right? So they won't be able to use it. So the first thing is that example, so I have mentioned this as well, the benefits, the reasons that are there, like there are limited resources that are there to serve everyone. For those services are there, so we have to put certain limits around that. DDoS attack is another thing. So even if we have certain legitimate use cases, still it needs to be limited, but there are some illegal or illegitimate usage. Some unwanted actors are out there who deliberately wants to attack on the servers that are there, to bombard the server, and so that others are not able to use it. That is what we name is the DDoS attack. To prevent those DDoS attacks, we have to put certain limits around that. And the very new nowadays, as I'm recording this video, there was outage from Microsoft outage, and many of the services from Microsoft Azure and other services were impacted around this one, and the root cause for this one was the DDoS attack. This is very old attack that is very prevalent. I'm sure you know about it, right? But the recent example, like why I want to mention it, the Microsoft, this is a very, like such a giant company, and you cannot think of what measures they have now, they might not have put in to prevent the DDoS attacks. Still they're impacted around this one. So attackers are also coming up with new ways to impact the services, so that prevention mechanism should also be evolving basically, so that we can prevent from these attacks. So rate limiter is one of the example, one of the way that we can prevent the DDoS attacks. Next is the costing also to provide. So if we have that service, right, so to provide these services, they might be using another APIs, right, another APIs services they are using databases also, and all of them are putting certain cost, right? So if they are not limiting those things for after a fair uses by individual user from individual locations, that cost will be piling up, right? So they will be incrementing. So to control that cost is also there as a limit. So these are some benefits, or these are some of the reasons that we need the rate limiters. What are the high level requirements from our rate limiter that we want to implement? If you are going to the interview or want to design rate limiter from the for your own system, these are the things that you should keep into mind. Like first thing is like this client side versus server side. So we have standard architecture, right? So we have client, we have server. So where to, and if we have this rate limiter, very first question is, where do I put this rate limiter? Should I put it on the client side or server side? And it depends, like what I want, whether I want to put it on the client side and server side. So I can create the rate limiter as a service. If let's say as a client, I'm a client and I'm calling this server, and this is costing me as per number of the requests I'm making in, and I have a contract like I cannot make more than 100 requests per minute to this, and after that it will be just declining those requests. So client can put these limits, client service can put these limits on the incoming request that it is getting, that after 100 requests per minute I cannot call this service, that is the supporting service basically. So anyway, even if I call it, that will be denied, right? So why not return it from here to the user? So this is the one use case that I want to put the rate limiter on the client side. Another use case, like let's pass it on to the server and let server decide whether it want to process it or not. And this server is also using a number of services, like if it has that quota, it has that cost and this limit available, it will process that request. So that is where I want to put this on the server side. Another reason, like if I pass that request on the server side, maybe at that point in time it is failing that request, but later in time it can process that request and it can pass that. So it all depends on the use case with what we have. So we can put the rate limiter on the client as well as server side as well. Second is the accuracy. So if I have put the number like 100 requests per minute, right? So this accuracy should be there, right? So if we have this time limit, like this limit, so this 100 requests per minute should be distributed throughout this 1 minute. It should not be like all the requests are coming at this point in time, at this point in time. So whatever the contract of the rate limiter says, that should be accurately following that. Latency, because rate limiter is a supporting service to serve the business purpose, right? So it should not take much time to process that limited, like to confirm whether this request is allowed or not. So it should confirm whether it is allowed or not as soon as possible. So latency is a very important factor. Distributed, we have lots of microservices in place to serve the business purpose, right? And we will be putting this rate limiter against each of the services. So there is like certain issues can come, like race condition is one thing. If we have to consider it, basically race condition, concurrency, and this along with this accuracy also comes into picture. If we are in the distributed environment, so we have to keep these in mind. We have to say that it is scalable, it is also fault tolerant, right? And it does not have single point of failure thing, right? Because single server is very much very much inclined to that single point of failure. If some certain thing can goes wrong, and it will prevent all the requests. So we should have certain default behavior around this if it is failing. Monitoring, so we have to monitor these things, like what clients are coming in. Even if we have automated mechanism, so we should have that mechanism in place that we can monitor clients, that how many requests they're making, and whether our servers are able to process those requests, latency, accuracy, these parameters are coming into picture. If certain thing is failing, what behavior it is giving, those things should be easily monitorable. These things are the requirement from our rate limiter services that it should implement. With these requirements in mind, let's have a very high level design, like how it will look like if we implement it. I want to cover this high level design, then again I will come to that algorithms, logics for the rate limiter that you saw on the first slide. So let's jump to that. So I have this tool rate draw.io, so where I want to draw certain diagram. So let's see, we have not this one, let's take the rectangle in here. Okay, and this is our client. So increase font a bit, 36. I hope this is now visible. So this is client. When we say client, this can be mobile and web both. Mobile clients and these things, right? So this is the client and this is calling the server. Okay, and let me copy this one and put this, and this is API server, and there are not one server but multiple servers are in place, and there is not one client, there are multiple clients in here as well. Okay, and now here our bird is in here, like that is rate limiter that we are discussing in here. Okay, so increasing font of 36, let's say this one. So now I was just saying, like, so this rate limiter can be placed on the client side and this rate limiter can be placed on the server side as well, as per the requirement that we have. So in this, as I said, there are multiple services in here, right? So the multiple microservices are there and client is calling, so they won't be calling the individual microservices, right? So I hope you have guessed that what is there in place to have these things, like API gateway. API gateway is there to serve that purpose, interface for calling, routing for multiple services that we have on the backend. So this rate limiter will be integrated ideally with this API gateway. So let me just put in this way. Okay, and let me make it a bit color. Okay, so this is API server, this is this is this, and this is our rate limiter. Okay, so this is how it looks like now. This is how it can have client, app server, API gateway, rate limiter is setting in here. Rate limiter, as we are seeing that this is going to be distributed in nature, right? So we have to store the configuration. We have to like whatever clients are coming in, we have to make what is the persistent system in this one. So keeping latency in mind and those things, so we are going to use Redis. So Redis can be used for this purpose, to store those configuration as we needed. Okay, and this this Redis is going to have those configuration stored as per the client. Whenever the request is coming from client, this will API gateway, rate limiter will call to Redis will fetch that configuration, like the limits that is allowed or not allowed, those configuration are in here, and then API server, as per this call, this will decide. So let's say this request is coming in here, right? So this is the request that is coming in here. This request will go to the rate limiter. Then rate limiter will decide whether to deny the request or pass the request. If rate limiter says yes, so this will pass on further, like let's say yes, this is allowed, right? Let's make it color a bit green. So this is yes. Another case is, right, it can say that this is not allowed at all because it has crossed that limit. So it will say that, sir, too many requests for you for the time being, and there is a code for this one as well, like 429. 429 is the code for this one that is being sent for this, and this one is going to be red in color. Okay, so if rate limiter allows that request, it will be served. If it is not allowed, it will be request too many requests. Client will get the notification that 429 HTTP code, too many requests, and request is declined. When API gateway is declining that request, it has two options actually. So what those two options are there? It can just straight away go and drop the request. A second option is just instead of dropping that request, it can put it for the reprocessing, like for later purpose. It can you can say like let me drop it, and this name that we are giving it like queue. So I can keep it in a certain queue internally that later on I can decide what to do with this request. So the first option, like right away dropping the request and relying on the client that it will take the decision. The second option is that I can put the request in a queue basically. Okay, and by putting those in a queue, I can later on decide whether to reprocess in certain ways those requests or not. Okay, so these are the things, these are the decisions that I can take around it. Another factor is around when we have many clients, right? Rate limiters are there. So another use case is that I have to keep changing or storing the config basically. This is yet another requirement that I have to, whenever that rate limiter is there, I should be able to change the config. That is where this backend process comes into picture, and here I can say that different writers are there, writer or workers, you can say writer jobs are there, or you can say API calls are there, and many options can be there, and it can just make this call and this will make this change in here. So the flow of this one, if any new client, any new use case I want to onboard, so that will be onboarded via writing the configuration in the rate limiters. For this one, database can be Redis also, it can be MySQL database also, because this is the configuration part. This will write the configuration, and when that call will come, rate limiter will decide whether that call is allowed or not. Based on that, it will just process the request, or it will decline that request with the 429 and put that in the queue, or it will just drop that based on the configuration or design that, or whatever we have decided. So this completes the high level design that we have, client, server, API gateway and all that. So I hope you got the clarity. Now coming to the next one. Next point, that we have algorithms, like the logics that we have to put in place. So when it comes to logic, we have different algorithms: token bucket, leaky bucket, fixed window is there, sliding window log is there, sliding window counter is there. So all of these are there. Each of these has its own pros and cons and use cases where we have to apply that. So the next and very important part is going through each and every algorithms that are there and understanding that how they work. Don't worry about the implementation and low level design. Subsequent in the video, I am going to create a rate limiter service also, where we will be implementing all of these ones. So don't worry about. Make sure that you watch it till the end, and other following video that I'll be uploading. Make sure that you complete it to get the complete picture about the rate limiter. So the first thing is that whenever we have these algorithms, there is certain input parameters, right? So we are saying this a bucket, right? So let's say we have let's say this is a bucket, sorry for the bad design, and it has certain capacity, initial size and refill rate. So let's say initial size is 4, and when we are saying this name, we are saying token, right? So initially this bucket has 4 tokens, right? And the second thing is like refill rate. So I want 4 tokens per minute. For example purpose, we are saying that it will be initially it has 4 tokens, right? And later on, each and every minute there will be 4 tokens coming into this bucket, and maximum 4 tokens are allowed in this one. So let's say the first use case is there, first one is there. So let's say 2 requests came into this one. So we have first minute, let's say 10 hour, 0 second, 0 minute and 0 second. Initially we have this 4 tokens, 4 token per minute is there, and 2 requests came into picture. So what will be the next state of this bucket? So this bucket will have 2 tokens left, and the time is there, let's say 30 seconds passed, right? Now we have 2 tokens in here. So 2 requests again came into this one, and it found that there are tokens available in the bucket. So what will happen? The request will be processed in here, and again it will reduce the number of tokens in here. So the next state of the bucket will be like no tokens are in there, and the time is there, let's say 40 seconds is there. Now let's say 1 request came into picture, it will check whether there are tokens available. So there are no tokens available, so this request won't pass further. This won't pass. This will be returned back with the 4 to 9 response. It won't be allowed because there are no tokens available. Let's say time passes. Now we are at 10, 0, 1 and 0 first minute, right? So we have that refill rate, right? So refill rate of 4 token per minute, because now we are starting next minute, right? So those tokens will be refilled in here, and if any request coming in now, it will check whether tokens are available. Yeah, this is available, this will pass it on, and the cycle will be repeated from in here. That is what the token bucket algorithm. What are the pros of this one? Very easy to understand, very memory efficient. What we just have to store the bucket size and refill rate as per the client, and it will process those requests. And what are the cons? So this point, I think burst of traffic for short periods, this should come under cons. Actually I just mistakenly put it in the pros. So what I meant by this burst of traffic, so let's say this is the 1 minute window. 1 minute is there, this is divided into this one. So initially it has 4 tokens, right? So if let's say all the 4 requests came into this time, whether they will be allowed or not, they will be allowed, because under 1 minute we have those things, right? So in this time only all the 4 requests will be processed, and during this time no request will be allowed. So that is burst of traffic is coming for short period in time, and later in time won't be allowed. So that consistency is not in picture here. That is the one cons. And another thing is like there is only 2 input parameters. Certain times it will be very difficult to tune these parameters. One thing is configured, we have to keep changes on this one, so there will be writer configs, we have to keep making those changes. So this is the cons of this one. But very easy to implement. It is very memory efficient and will be perfectly fine for certain use cases. So that is all about the token bucket. As I said, implementation, low label design coming in the next videos. Okay, so don't worry about that one. Next one that we have is the leaky bucket. what is the input parameter for this one? This is again Leaky Bucket is implemented actually using queue into picture. So let's see how it works. So bucket size, the queue size you can say is the input parameter for this one, and outflow rate is there. So let's say this bucket is divided into, this queue is divided into certain parts in here. Let's say initially it has 1 2 3 4 5. So this is the capacity actually, capacity or size of the queue is there. If any new request is coming into picture, it will check whether queue is empty or queue has any available capacity in here. So as this is the first request that is coming in, so it will be just queued in here, okay, and this will be allowed because it is there, we have capacity available, right? So again it will be outflow rate. So let's say the outflow rate is like 4 requests per minute. It is processing 4 requests per minute. Again capacity is 5, so let's make it consistent, right? So 4 requests per minute, 5 requests per minute in here, okay, and capacity is there. So let's say 1 request came in, this will be coming in here, and outflow rate, this will be processed consistently on this one. And let's say as a second step, so let's say at next time 3 requests came in, so let's say timing is also there. So at first second these first request came in, this will be processed. Third request is coming into this one, so again this queue is going to be there, 1 2 3 4 and this 5. So again these 3 requests will be queued in this one in here, right? And the processing will happen at a like this rate, 5 requests per minute. Let's say this is happening at 0 and this 10 second, and again at next time we have again 4 request coming in here. So let's say outflow rate took care of the first request and it processed. Still 2 requests are pending, so 4 requests are coming in here, right? So this is there, and let's say 4 not the next time it came the 5 requests. So 4 requests will find that capacity is available, it will be queued in here, but this one won't find any space, so this will be dropped from here, okay. So here based on the capacity of this one, the incoming request will be processed and it will be decided whether the new request is allowed or not. So what are the pros and cons of this one? Fixed rate of request processing, like outflow rate is no matter like 100 requests per minute is coming in to the server, doesn't matter, the processing rate is fixed, like this 5 requests per minute. Every minute 5 requests will be processed based taken from the queue only, okay, and this is memory efficient if the bucket size is limited. What are the cons of this one? Burst of request filled with older requests. Let's see, I think you have guessed it, like because this is the queue, first in first out. Let's say all the 5 requests came in at a first second, they will be queued in, but the processing rate is 5 requests per minute. So the request came in first second, but during that 1 minute only those 5 requests will be processed. Rest of the request that is coming for next 59 seconds, they will be declined. So the old requests are processed, the newer requests are declined. So that is one of the cons that you can consider. So might not be easy to tune the input parameters, that we have limited like 2 parameters. This is the cons with this algorithm as well. Fixed window is even more easy to understand. So here input parameter that comes into picture is a window size and max request. So what happens, you see this timeline, basically entire timeline is divided into certain time windows basically. So let's say we have 1 minute of time window. So this is the first minute, this is the second minute, this is the third minute, this is second minute, this is the third minute. This is how the entire timeline is divided, right? And for each time window that we have, there is a max request parameter. So let's say there is a 5 requests that are allowed in the given window size, okay. So let's say in the first minute, so number of requests that is coming into this time window, 3 requests came into place. So while implementing this is relatively easy, like you start a counter in a certain current time is time and just keep track of the last minute that is there. So if that counter, that whenever that request is coming in, just increment that counter and compare it that with the threshold. So if that is within that threshold, just allow that. Let's say this one, in this first minute it got 3 requests, right? So it will be allowed because it is less than the threshold. In the second minute, let's say 1 2 3 4 5, and in this one we got more requests, like 8 requests came into picture. So these 5 requests will be processed, but these one will be declined. In this one the same will continue to be there. So this is even more easy to understand and very easy to implement. We have divided into fixed time windows. Each time window has a this max request, that how many are allowed, and just have to keep a check on that one. So pros and it is memory efficient and very easy to implement, but spike in traffic at the edges. So let's draw this again, right? So this is there, okay, and let's say this 1 minute is there, and this is the first minute and this is the second minute. Okay, so let's say all the 5 requests that came into picture, 1 2 3 4 5, this 5 request came into at the edge, let's say at the 59th second it came into picture, and at the start of the next minute, at the first second only, all the 5 requests came into picture. So there is a burst of requests. So ideally this is the 59, this is the first second, so we have this 2-second window, right? In this 2 second we processed 10 requests, right? See the problem with this one. So this is a spike in traffic at the edge is possible with this implementation. So moving towards the next one, that is sliding window log. So this is, in this one also we have those 2 parameters that we had initially, window size and max request, but implementation is a bit changed in this one. So what was happening initially, we just had fixed window, right? Fixed window, but now we have sliding and log also. So what we are doing, so time stamp is creating a important role in here, right? So we just have to keep track of the time and we just have to add it. So let's see how we do it. So window size here again, let's say for the sake of easy implementation, let's say there are 2 requests per minute that are allowed. 2 requests basically. No, sorry. So max request is 2 requests, okay, in a certain time window that we have decided, and time window is the 1 minute. So essentially we have 2 requests per minute. Okay, so let's see. So whenever the first request is coming in, so this is the first one. So this is the first request coming in. So let's say we have to log the time basically. So let's say the time is 00, and this is the first second that is in here. So 10:001 it came, and after adding that log, that we have to just count it. So we added the time and we counted this bucket in here. So it is 1, right? So 1 less than 2, the request will be allowed. So let's say the second stage come into picture. So we already have this 10:00, this 01 in here. At the next let's say 20th second, 1 more request came into picture, right? 20th second, 1 more request came into picture, and we added this in the counter in our bucket in here, and we counted like 1 and 1, so 2 less than or equal to 2. This is within the limit, right? And this will be allowed again. Okay, so next, move ahead. Moving, the next time is stamp is there, like 10:0001 is there, and this 10:00, and it was 20, and the next one is that is 10:00, that is like 40. Let's say this is coming as a 40. So this one, after adding the time stamp, it will count. So this is coming as a 3, which is greater than 2, right? Greater than threshold basically. So it won't be allowed. So this request will be dropped in here. Coming to the next one that we have. So now we have 10, 0, all of these times are logged in here, right? So 10 0 0 20 and 10 0 0 40, and the next request that came into like 140 in here. Let's say one next request that came into picture, let's say not 140, let's say 120. Okay, so what it will do, it will just add the timestamp in here, and before adding the timestamp, it will just keep track of the previous one. So it is coming at a 10:120, so it will go 1 minute back, 1 minute gap back. What is there? So 1 minute back, this is 20 and this is 1. So it will just clean this out, remove these things, and after removing this, it will add this one and will add, like, count the numbers, like, so it is again 2, right, which is within the threshold. So this will be allowed. So it is keeping two things. It is basically sliding the time window in forward, so that the previously that it was happening, like burst of traffic at the edge of the times, that won't happen in this case, because it is taking into account the relative time, basically what is the current request that is coming into picture. So very accurate. Request will not exceed the rate limit, and consists lots of memory because we have to store the timestamp for each request that is coming in here. Although we are like cleaning up the previous ones, but it will take up memory. We are storing the time as per the like whatever we have previous algorithms. So this is the final algorithm, sliding window counter. So this is basically the combination of the previous two algorithms that we have, fixed counter and sliding window. Okay, so this is you can say that hybrid of both of that one. So let's understand this. So in this case also, that timing is a factor in here, and let's say this is the number of requests, right, and this is the 1 minute, like this is the first minute and this is the second minute. Okay, so why am I saying this will make sense in a minute, just bear with me. So let's say our system allows 7 requests per minute. Okay, 7 requests per minute it is allowing. So in this complete 1 minute, let's say 5 requests came into picture in this time window, and this time window, let's say this is a 70%, and this, when second minute starts, let's say 3 requests came into this one, that is 30% of the time. How the current number of requests will be calculated? So this will be requests in current window, that is 3, plus request in previous window, that is request in previous window, like that is 5 into this percentage, whatever this one was there. So this turns out to be 0.7, right? So by calculating this one, we will get the number, that is 6.5. 6.5 will be compared with this 7 requests per minute because it is within the limit, and as per our understanding, like whether we can say this 6.5 to be at 6 or we can say that 7 also, we have to go with the consistency, but we can go any of this one. Let's say we go with this one. So this is within the limit, right? So this will be allowed. Let's say one of the example where this won't be allowed. Okay, so let's say this increase this one, and let's say this 90%, this 5 requests were processed in the 90%, this will be 9. Okay, so what is the calculation that will come? So it will be turning out to 4.5 and plus 3, and this will be 7.5 basically. So this is again, if I take this number as upper limit, that is 8, so this also won't be allowed because 7 is less than 8. So this is the reason. So what is the benefit out of this one? Like it is sliding the time also, and also considering like how much, at what interval, at what percentage of time that number of requests were processed. That is why it makes use of both counter and fixed window, and that is how it comes like a reduced edges of the window, more accuracy as well as, so there is no burst of traffic, smooth traffic control is there, and memory use is also reduced from the previous ones because I don't have to store the timestamp and all that. Cons, it is less accurate. complex implementation. Like you saw, if you try to understand it theoretically also, compared to the previous algorithm, it's a bit difficult to understand, right? Because we have to take into account the formulas and this one percentage in this one and in here. This will make more sense when we are implementing, and we'll see how much complex it is, right? So these are all 5 algorithms that I wanted to explain. The final slide is like, what is the decision factors that that we should keep in mind while trying to pick any of these one. So the first one is that traffic pattern. What is the traffic pattern that we have? Resource constraint. What is the resource constraints that we have? Rate limit precision. So how much precision accuracy do I need from my logic, that is rate limiting algorithm? So that should decide this one. Implementation complexity, burst handling. So these are the couple of factors that should be taken into account while picking any of the algorithms that we need. So these are the factors that should be considered. So that's it about rate limiting theoretical lecture, high level design, as well as understanding each and every algorithms. As I said, we are going to implement each of the algorithms. That will give us more clarity how it works internally and what are the low level designs around this one. So if you found this video useful, please don't forget to subscribe and like the video and share it with your friends. So I'll see you in the next one. Till then, take care. Bye bye.